Okay, hi all, myself Ratnakaram Raju from the competitive.in, the one and only platform at your service at any time to enhance your skills. In the last video, we discussed about force and friction, which are the basic and important topics in physics. In this video, we need to discuss about reflection of light in plane and curved mirrors. Okay, then go to the next slide. Reflection of light on plane and curved mirrors. As we know, in many of the competitive exams, direct and indirect questions are being based on the light mainly. Those questions are from the above topic. As I said, topics regarding the light are reflection, refraction, dispersion. First, go to the reflection. What is meant by reflection? If any inserted or incidented ray is reflected into the same substance or medium, then it is called a reflection. Then go to the refraction. What is meant by refraction? As we know, for example, take two mediums or two substances. Substance one is air and substance two is water. As we know, there must be some similarities or differences in the densities of the two substances. Let's take a incident ray I1 which is fall on the axis of the two substances, and the second medium or the second substance is water. Then the incident ray is refracted into the another medium which is water. Here the refracted index or refracted angle of refracted index is less than, sometimes greater than, the incident ray. In the reflection, the angle of incidence and the angle of reflections must be equal, and the here angle of incidence is denoted by I, and angle of reflection is denoted by R, where we know I equal to R. Dispersion is also one of the main topic, as we know rainbow, as we all know about rainbow, and the rainbow is formed basically on the depends upon the dispersion. I say how it formed. Let's take a bubble. As we know, the rainbow is formed mostly when there is a situation of raining and the climate is cool, and some of the clouds may distract, and we have to observe the rain, and we have to know the rain, feel of the rain, and the rain will comes from the up. As we know, some of the drops there acts as the medium, and a incident ray and a ray from infinite distance fall on the water drop at one surface and dispersed or dispersion into many rays. That is called as a VGR: violet, indigo, blue, green, yellow, orange, red. These colors are observed in the rainbow. This is how the rainbow is formed. Next, go to the curved mirrors. Curved mirrors are mainly of two types: concave, convex. As I shown in the picture, the first one is the concave, where the rays from the infinite distance are converged to one point, and next in the next diagram, all the rays from the infinite distance are diverged to another point. This is called a convex. Let's go through it. Okay, let's go to next slide. Concave mirror. Concave mirror is mainly known as converging mirror. As we know, the rays from the infinite distance are converged to a point, so it is called a converging mirror. Frequently asked question: why concave mirror is called as a converging mirror? As I explained earlier, all the rays from the infinite distance are converged to a point called as the focus, which is at a distance focal length from the critical pole. So it is called as a concave mirror is called as a converging mirror. Let's see focus, critical point, center of curvature. Focus is a point where it lies on the principal axis at a distance of focal length small f. It is denoted by small f from the critical point. And the next is a critical point. Critical point is also point which lies on the center of the mirror. For example, let's take a concave or convex mirror. Critical point must be lies at the center of the point, and it is there itself the principal axis starts. Center of curvature. Center of curvature is also the point where it lies on the principal axis at a distance of radius of curvature, which is denoted by capital R. The distance between the critical point and the center of curvature is R. So the focus point must be lies at the center of the both. So we have to observe this R, capital R equal to 2f. Here f is the focal length. Next, go to next slide. Convex mirror. Convex mirror is a diverging mirror in which the reflective surface bulges towards the light source. As I said earlier, as the rays from the infinite distance falls on the surface of the mirror, the rays may diverge to another. So it is called as a convex mirror. As we know, the convex mirror are not used to focus light as they reflect light outward. Okay, the image formed by the convex mirror are smaller than the object, but gets are larger as they approach the mirror. As we as we take some of the uses of convex mirror, there we can understand what is convex mirror importance. Okay, let's take a car. For example, let's take a car. As we know, in the car we have a side mirrors, rear view mirror, indicator mirrors, and many others. For example, the mirror which is used in the headlights are also is called as a concave. Why? Because the bulb which gives the rays, all the rays are converged to a point, so it is a concave mirror. Let's take a side view mirrors and the rear view mirrors. As we know, what is meant by rear view mirror? Rear view mirror is a mirror which is between the driver and the another seat. Okay, upside. The both mirrors, rear view mirror and the side view mirrors, are of convex mirror. So the upright image will be observed. As we know, as we seen or as we know, some of the lines are written on the side view mirrors. Objects in the mirror are closer than they appear. Okay. Uh, Convex mirrors are also used as reflectors in streetlights because they are able to spread the light over a wide area. As I said earlier, many of the rays from the infinite distance fall on the surface of the convex mirror. They need to diverge, so it is a principle used in the streetlights. Okay. Next, go to the another slide. Reflections in the plane mirror. Let's take a plane mirror, and here the red line is called the incident ray, and the green ray is called reflected ray. I is the angle of incidence and r is the angle of reflection. Here n is the normal which is between which lies between the I and r. Okay, next go to the another slide. Curved mirrors. Curved mirrors are of two types: concave, convex, as I said earlier. And let's take mirrors as part of a sphere. Here the concave and convex mirror are a small part which is taken from a curved sphere of mirror. I hope you understand here the point. Concave and convex mirror are the small parts which are taken for our assumption to know the images and upright images to know the correct spectacular images. We taken some of the part of the hollow sphere. Okay, and as I said earlier, pole, center of curvature, principal axis, radius of curvature, all the terms are denoted here. And let's have a look here. Okay, and next go to this another slide. A diverging mirror. As we know, I hope you know why I mentioned diverging mirror. First we need to know what is the diverging mirror. It is a convex mirror. Okay, let's see some of the object and image placements in the convex mirror. First one, object behind C. C is the center of curvature. Let's take it, and let's place a object, whatever it may be, candle, object, tree, whatever you assume. Let's place it behind C. Behind C means what? It must be between C, center of curvature, and F. Here the image lies on the right side of the mirror. Here, as I shown, O is the object and I is the image. Okay, let's go to 2. Object between C and F. Here C is center of curvature and F is focus. The object is O, and as the rays on the falling, and the image formation is on the right side of the mirror, and it is denoted by I here. Let's go to the third, object between F and V. Here F is the focus and V is the point on the mirror. It is called as a critical point, as I said, and the object is denoted by O, and I is denoted by, image is denoted by the I here. Okay, let's take 4, object at F. Here F means focus point. If you place an object at F, the image will be always placed on the right side of the mirror, as is shown here I. And let's take to object at C. C means center of curvature. As we all observed in the convex mirror, all the images are formed on the right side of the mirror. Okay. Okay. Let's take some of the terms in converging mirror. What is meant by converging mirror? A concave mirror. Okay, let's take here. Let's take some of the examples which are shown here. For example, A at infinite distance. A is a object. Let's take A is a object from at infinite distance. The rays are followed on the concave surface from infinite distance are converged to a point called focus. And as we know, many of the rays are falling. No, then one of the ray must be fall on the center of curvature. Then if you place object at infinite distance, the image will be formed at focus point. Let's go to B. If you place an object at behind C, then the object rays must be fall on the surface of the mirror and the image must be developed or formed in between the center of curvature and focus. Let's go to the C. If you place a object exactly at C, center of curvature, the image must be formed or developed same at the center of curvature but upside down. Let's go to D. If you place a object between center of curvature and focus point, the image will be formed or developed behind C. Here the image formation is bigger than the object and it is also the upside down. Let's take E. If you place an object at a focus point, the rays from the object will fall on the surface of the mirror and it goes to the infinite. As we know, the object at F must be developed and the image will be developed or formed at infinite distance. Okay, let's go to F. If you place a object between focus point and critical point, the image will be developed or formed at right side of the mirror. It is a real image. As you know, it is the only one condition where the real image are formed in the concave mirror. It is a direct one which is frequently asked in many of competitive exams. So what I said means, let's have a brief look about all the mirrors, the concave and the convex mirror, the uses and some of the reflections we need to know, and we have a brief look and have to prepare well about this. And next, okay, uh, this is all about reflections. I hope I covered all, and I hope all you understand well. And if you have any doubts, ping me and let me know in the comments section, and we will discuss the remaining topics in next video. Thank you. Yours RATNAKARAM Raju, the competitive data. Thank you.